So in this video, we'll be learning how to find the derivative of a parametric equation. Now in our last video, we covered how do we graph a parametric equation, how do we convert a parametric equation to a Cartesian equation. So if you want to check that video out before watching this one, it will be highly beneficial. And the basic recap is that a parametric equation is x and y in terms of t. So that is the main thing. And to find the derivative of this equation, all you have to do is take y prime, which is equal to dy over dx, which is broken down into dy over dt. So we are deriving in terms of dt, so I mean t, and the same for dx, so dx over dt. And now once we do an example, this will be more simple to understand. So question 1 is to find the slope. So slope is, by the way, the derivative, so don't get confused, of tangent line at t is equal to pi over 4, and when we know that x is equal to secant t and y is equal to tan. So let's just apply the formula, and this time in this question we are given a t value, so we'll just substitute this in the final answer. So now the formula is dy over dt, so we derive the y function over dx over dt. So what is the derivative of tan t? Forgot to write t over here. It is going to be secant squared, right? So you need to know all your basic derivatives of trig functions and normal functions also. And the derivative of dx over dt, or secant t, is secant t tan t, and we can cancel the one of the secants. So now we are left with, or let me just write that and just cancel this way. So now we are left with a secant t over tan t evaluated at t is equal to pi over 4. So now all you have to do is substitute pi over 4 in t here, and you will get the final answer as radical 2. And that's basically it. So it's very simple. Now let's do another example. This time you can pause the video and try to do this example yourself. So x is equal to t and y is equal to radical t, and we are calculating the derivative at t is equal to 1 over 4. So again, I'll just dy over dx over t dt and dt is equal to, what is the derivative of radical t? Is going to be t squared to the power of half. We take half down, so it's going to be half t, and half minus 1 is negative half power, and we can take this down, so it's going to be 1 over 2 radical t over, what is the derivative of t? Is with relation to t, it is just going to be 1, right? Because we are deriving in terms of t over here. So if, let's say, we are deriving x squared in terms of x, it's going to be 2x, right? And now if we derive this again in terms of x, it's going to be x to the power of 0, so just 2. So the same thing applies over here, so it's going to be 1 here, the derivative of t. So now we just have to all we have is this part over here, so 1 over 2 radical t, and we just evaluate this at t is equal to 1 over 4, and we get the answer of 1. Okay, now let's move on to a more challenging part of this video, where we have to find the double derivative or double prime of a function, of a parametric equation. And it is not the same way as a Cartesian equation. Let's say we have x squared, like this example. The first derivative is 2x and the second derivative is 2. So we can't just do that here, and we have to use the formula. So let me just scroll up. So y prime is equal to this. Now y double prime is going to be equal to d squared y over dx squared over, now this is quite similar to quotient rule, so the denominator stays the same, dx over dt, and now in the numerator we have dy prime over dt. And for y double prime, we have to find the first derivative first in order to get the second one. And you will see this in the next example. So we have question 3 now, and x is equal to t minus t squared, y is equal to t minus t cube, and we need to find double prime, so d squared y over dx squared, which is equal to y double prime. And so again, the first step is to find the first derivative, which is dy over dx is equal to dy over dt over dx over dt, which is equal to, what is the derivative of t minus t cube? It is going to be 1 minus 3t2 over the derivative of x here is 1 minus 2t, and this is our y prime. Now for the second derivative, we will write it over here, so d squared y over dx squared is equal to dy prime over dt over dx over dt. So remember that the denominator is the same as the first prime, so we can just write that as is, so 1 minus 2t. And now this part, the numerator, is deriving the first derivative. So we have y prime and we derive it one more time with respect to t. So as we have this entire thing, which is a fraction, so we need to use quotient rule over here, right, to be able to derive y prime. And quotient rule is u prime v minus u v prime over v or v squared. And let me just write it over here, u over v prime. So remember this formula, even I forgot it right now. So u over v prime is equal to u prime v minus u v prime over v squared. And now we apply that formula to this fraction. It is going to give us u prime is, I'm going to write it over here, so minus 6t multiplied by v, which is just as is, so minus 1 minus 2t, minus u is going to stay the same, so 1 minus 3t squared multiplied by v prime, which is going to be minus 2 over 1 minus 2t squared, right? Now let's simplify this, and you will get the numerator as 6t squared minus 6t plus 2, which is simplification, by the way. So now this is our numerator over here, so let's just write it over there. It's gonna give us 6t squared minus 6t plus 2 over 1 minus 2t squared. And let's simplify this now. So we have three fractions like this. So what we can do here is just take a smaller number, let's say 1 over 2 over 3. So how do we simplify this? We just multiply these two denominators, right, to get 1 over 6, and that's what we're going to do over here. So I'm going to erase this, and if we multiply 1 minus 2t squared with 1 minus 2t is going to give us 1 minus 2t cube. And now we can write this larger, so 6t squared minus 6t plus 2. And that is our final answer. And since they didn't give us any value to substitute t as, so this will be your final answer. So now another thing to keep in mind is, for example, in this last question that we did, we were given that in the final thing we had to substitute t is equal to 1 over 4. Now sometimes in the exam, instead of giving you t, they would provide you with, let's say, y is equal to 10, for example. So what you have to do here is you have to go back to the parametric equation, which is y is equal to radical t, right? So 10 is equal to radical t, and then you find t, which is going to be 100, and then you would substitute t here as 1 over 2 radical 100, or sorry, yeah, t is 100, so yeah, radical 100, which is 10 basically. So that's another way of the question in the exam. Or they can give you x is equal to, let's say, 2 or 20. So you go back here, and here we have x is equal to t, so it's the same thing. And yeah, so that's all for this video. I hope that you understood this topic. If you have any questions about anything that we covered in this video, feel free to ask in the comment section. I'll be more than happy to answer. And thanks for watching.